Hey everyone, and welcome back to the All Sorts podcast. You know, we dig deep into all kinds of fascinating topics.
And today we're taking you on a journey.
A journey into the world of subnetting.
Subnetting. It might sound a bit technical.
Yeah, a little bit like Star Trek-y almost.
But it's a concept that's more relevant to our lives than you might think.
Okay, I'm intrigued. So what is subnetting?
Imagine the internet like a massive highway system.
Okay, I can see that.
With millions of cars all trying to get to different destinations.
Sounds a lot like rush hour in my city.
It can get pretty chaotic, right? So subnetting is like creating smaller roads and neighborhoods within that massive highway system.
So instead of everyone being on one giant superhighway.
Yeah, divide it up, make it more organized.
So it's all about organizing the internet.
Exactly. And that organization brings a whole bunch of benefits.
Like what?
Well, for starters, think about traffic flow.
Okay. Less congestion.
Yeah, if we divide that massive highway into smaller roads.
Data can move faster.
Yeah, it's like creating express lanes for information.
So faster internet speeds.
Absolutely.
Okay, I'm liking this already.
But there's more to it than just speed. Subnetting also plays a key role in security.
Oh, interesting.
Think of it like this. If you have a giant building,
Okay.
you probably want different levels of security for different areas.
Right, so you don't want just anyone wandering into the server room.
Exactly. Subnetting allows us to create those secure zones within a network.
I see. It's like having different security clearances for different parts of the internet.
That's a great way to put it.
Okay, so subnetting is good for speed and security.
It also makes network management a whole lot easier.
Okay, how so?
Imagine trying to find a problem in a network with thousands of devices.
Sounds like finding a needle in a haystack.
It can be a real headache, but subnetting breaks that giant network down into smaller, more manageable chunks.
So it's easier to troubleshoot problems.
Absolutely.
Okay, I'm starting to see how this all works, but how do we actually create these subnets?
The secret lies in a combination of IP addresses and something called subnet masks.
IP addresses I get. Those are like unique ID numbers for every device on the internet.
Right. Every device needs an address, so it can send and receive data.
Like a digital home address.
Exactly. And subnet masks tell us which part of that IP address belongs to the network and which part identifies the specific device.
Okay, so the IP address is like the full address.
And the subnet mask is like a filter that shows us the street name versus the house number.
I see. It's like a decoder ring for IP addresses.
That's a great way to think about it.
So by adjusting the subnet mask
Network administrators can create different sized subnets.
and control how many devices each subnet can handle.
Exactly. So we've got IP addresses, which identify devices.
Subnet masks, which help us create these subnetworks.
It's all starting to come together.
This is fascinating stuff.
Yeah.
But I have to admit, it still feels a bit abstract.
Sure, I understand.
Can you give me a real-world example of how subnetting is used?
Absolutely. Let's say we have a small business.
Okay.
They've got a network with all sorts of devices.
Computers, phones, printers, maybe even security cameras.
Exactly. And they want to organize all of those devices into separate subnets.
Okay, so they might have one subnet for their office computers,
Right.
another for guest Wi-Fi,
And maybe another for their security cameras.
to keep those separate from everything else.
Exactly. So
Okay.
they would use subnetting to divide their network,
Create these separate
to
zones,
improve security,
make their network run more efficiently.
and make it easier to manage,
So it's like carefully planning out a neighborhood.
making sure everything is in the right place.
Okay, so we've got the basic idea, divide and conquer. But how do we actually choose the right subnet mask?
That's where things get a little more technical.
Is there some secret formula?
There's a bit of math involved, but before we jump into that,
Okay.
there's one more important concept we need to understand, CIDR notation.
CIDR notation.
Mm-hmm.
Sounds a bit like a secret code.
It's not really a secret. It's just a shorthand way of writing subnet masks.
So instead of writing out this long string of numbers,
We use a slash and a number.
like 24.
Exactly. It makes things much easier to read and write.
Okay, so we've got IP addresses, subnet masks, and now CIDR notation. I feel like we're building a solid foundation here.
You're doing great.
But how does it all tie together? How do we actually use this knowledge to create subnets?
That's where the real fun begins, and that's exactly what we'll be exploring in the next part of our deep dive.
Sounds good to me. I'm ready to roll up my sleeves and get my hands dirty with some subnetting.
Great. We'll be right back after a short break to dive into the nitty-gritty of subnetting calculations and techniques.
Can't wait.
Welcome back to the All Sorts podcast, ready to dive into the nitty-gritty of subnetting.
You bet. Last time we talked about IP addresses, subnet masks, CIDR notation.
All the building blocks.
Right, all the ingredients. but I'm eager to see how we actually bake this subnetting cake.
Okay, so let's imagine we're network administrators for a company.
Right.
And they've given us this IP address block to work with, 192.168.1.024.
Okay, so that's our starting point. A block of IP addresses.
Our digital dope.
Now what do we do with it?
Well, we need to divide it up into subnets for different departments.
Like marketing, sales, engineering.
Exactly. And let's say our engineering team is working on some top secret project.
Top secret sounds serious.
They need a lot of IP addresses for their devices, at least 100.
Ah, so we can't just divide our IP address block into equal chunks.
Right. We need to get a bit more creative, and that's where VLSM comes in.
VLSM, that sounds pretty high-tech.
It stands for Variable Length Subnet Masking.
Okay, and what does that mean exactly?
Think of it like slicing a pizza.
I like pizza.
Instead of just cutting it into equal slices,
Right.
VLSM lets us create slices of different sizes.
So we can give engineering a bigger slice because they have more devices to feed.
Exactly. To accommodate 100 devices, we need at least 7 host bits.
Host bits. Remind me what those are again?
They're the part of the IP address that identifies the specific device.
Okay, and each host bit can be a 0 or a 1.
Right. And 2 to the power of 7 is 128.
Which gives us enough addresses for all of engineering's devices.
Plus some room to grow.
Okay, so how do we translate these host bits into a subnet mask?
Well, we started with a 24 network.
Meaning 24 bits for the network portion of the IP address.
Right. And to get 7 host bits, we need to borrow one from the network portion.
Leaving us with a 25 subnet mask for engineering.
Exactly.
Okay, so engineering gets a 25. What about the other departments?
We can use VLSM to tailor the subnet masks for each department.
Based on their needs.
So if marketing and sales only need around 50 devices each?
A 26 mask would work for them.
Right. And for the guest Wi-Fi, which probably has even fewer devices...
We could use an even smaller subnet like a 27.
You got it. So we've figured out our subnet masks.
25 for engineering, 26 for marketing and sales, and 27 for guest Wi-Fi.
Now we need to actually assign those addresses within our original block.
So it's like we've divided the pizza.
Now we need to put the toppings on each slice.
Make sure everyone gets their fair share.
Exactly. We start with the largest subnet engineering with its 25 masks.
Which needs 128 addresses.
So that subnet gets the first 128 addresses in our block from 192.168.1.0 to 192.168.1.127.
Okay, engineering's taken care of. What about marketing?
They also use a 26 mask and 64 addresses.
So their subnet starts where engineering left off.
Right. 192.168.1128 to 192.168.1.191.
And then sales gets the next 64 addresses.
From 192.168.1.192 to 192.168.1.255.
Perfect. We've allocated all the addresses in our block using VLSM.
Every address has a purpose. Every subnet is perfectly sized.
This is amazing. It's like creating a perfectly organized digital city with each neighborhood meticulously planned.
You're thinking about route summarization.
Route summarization. Fill me in.
Imagine every router on the internet needed a map to every single device in our network.
That'd be a lot of maps.
A ridiculous amount. Route summarization simplifies things.
Okay.
Instead of listing routes to every single subnet,
Right.
we can advertise one route for our entire block, 192.168.1.024.
So external routers only need one map to find any device in our network.
It's like telling someone to go to a city instead of giving them directions to every house on every street.
Much more efficient.
And it helps keep the internet running smoothly.
I'm starting to feel like a real network wizard. VLSM for internal organization, route summarization for external efficiency. It's all connected.
And speaking of connections, you mentioned CIDR earlier.
Yeah, that shorthand way of writing subnet masks.
Well, CIDR is more than just a notation.
Oh.
It's a whole set of rules that govern how IP addresses are allocated on the internet.
And why is that important?
Well, remember how I talked about IPv4 and the limited number of addresses?
Right. Could we actually run out of IP addresses?
We were getting close, but thankfully we now have IPv6.
With way more addresses.
Almost an unlimited number, but CIDR principles are still relevant.
Even with IPv6. Why is that?
Well, imagine you're managing a giant library.
Okay.
Instead of assigning a unique number to every single book.
You could group books by subject and assign a range of numbers to each subject area.
Exactly. That's essentially what CIDR does.
So it's about organizing IP addresses into blocks.
And managing those blocks efficiently.
To make sure IP addresses are used wisely.
And to keep the internet running smoothly.
This is incredible. Subnetting is so much more than just a technical concept. It's the foundation of how the internet is structured and organized.
You've got it. And there's even more to explore.
Really? What else is there?
Well, we've talked about the concepts, but there are also a bunch of tools and resources that can make subnetting easier in practice.
Tools? Like what?
Things like subnet calculators and network design software.
Okay, sounds interesting. Tell me more.
Let's dive into that after a quick break.
And we're back for the final part of our deep dive into subnetting. I'm excited to hear about these tools that can make subnetting easier.
Yeah, we've covered a lot of theory, but in the real world, you don't want to be stuck doing all those calculations by hand.
Yeah, I can imagine it gets pretty tedious, especially with large networks.
That's where subnet calculators come in.
Subnet calculators sounds like a lifesaver.
They're like little digital wizards.
Okay, how do they work?
You just plug in your IP address, block the number of subnets you need,
Or the number of devices per subnet.
and the calculator does all the math for you.
So it tells you the subnet mask, the network address, the usable IP addresses.
It's like magic.
That sounds incredibly helpful.
Uh-huh.
Are there different types of subnet calculators out there?
You bet. There are standalone apps, online tools, even features built into some network management software.
So no matter what your tech skill level is, there's a subnet calculator out there for you.
Exactly. And another helpful tool is network design software.
Network design software, what does that do?
It lets you visualize your network.
Oh, so instead of just seeing a bunch of IP addresses and subnet masks?
You can actually see a map of your network with all the subnets and devices laid out.
That sounds really helpful.
Yeah.
Especially for understanding complex networks.
It's like having a blueprint.
You see how everything connects.
And identify potential issues before they become real problems.
I see. So subnet calculators help us with the calculations in network design software, helps us visualize our networks. Are there any other resources that can be helpful?
Absolutely. The internet is full of information about subnetting.
Websites, tutorials, videos.
You name it. And there are also books, courses, even certifications if you want to dive deeper.
So much to explore. This deep dive has been an eye-opening experience. Subnetting went from being this mysterious concept to something I can actually understand and use.
I'm glad to hear that. And remember, subnetting is an ongoing journey.
Technology keeps evolving.
There's always something new to learn.
Well, I'm definitely excited to keep learning. And I'm so grateful for your expertise. It's been a fantastic experience.
My pleasure. And for all of you listening out there, keep those networks running smoothly and efficiently.
And that wraps up our deep dive into subnetting. We hope you enjoyed this journey as much as we did. If you're eager to explore more fascinating topics, subscribe to the All Sorts podcast on YouTube.
And follow us on X, Instagram, and Threads.
We've got a whole library of deep dives waiting for you on all sorts of subjects, from technology and science to history and culture. There's something for everyone. And if you found this episode helpful, don't forget to give it a thumbs up and share it with your friends. Let's spread the knowledge, love.
Until next time, keep exploring, keep learning, and keep those networks humming.
See you in the next deep dive.